Bismillahirrahmanirrahim. Dear students, today I come up with question number 1 of exercise 9.2. This is the question which is related with the chapter that is known as circle. Dear students, the question is written as from a point Q. The length of the tangent to a circle is 24 centimeter and the distance of point Q from the center is 25 centimeter. So find the radius of the circle. Dear students, in order to understand the question, let's make a rough sketch of the question in order to understand it. So let's take this as the circle. Dear students, if we are having a point here, let's take this point as the Q. This is the external point. And let's denote this point as Q. And let's take here is a point, and if we will draw a line, if that touches the point, a circle at one point, and this is known as the tangent. As you are aware about the tangent, it is a line which touches the circle at one point, and the length of the tangent to a circle, it is given, and it is equal to 24 centimeter. And then the distance of Q from the center, let's take this as the center of a circle, and it is the distance of the Q from the center, and this distance is equal to 25 centimeter. It is like this. And let's have this is the radius of the circle that we have to find. Here, dear students, we have to find this radius of the circle, that is this O, and let's consider this point of contact, and it is equal to P here. So we will take it as we know the tangent and the radius, they are always perpendicular to each other, so it means we are having a triangle here POQ, but it is right angled at P. So it means this is the hypotenuse and this is the perpendicular side, and let's consider this as the base side. So we will write it as, we know that tangent PQ, it is perpendicular to OP. So in right angle triangle, the two sides are known here, this the hypotenuse and the base 24. So we have to calculate the third side of the right angle triangle. So what we will use here, we will simply use here the Pythagorean theorem. So we will write it as, in right angle triangle PQO, right angle at P. So what we will use PGT. So once we will use the PGT says the hypotenuse. So dear students, this is the side which is opposite to the greater angle. So this is known as the hypotenuse, because the side opposite to the greater angle is the greater side of a right angle triangle, and the greater side of a right angle triangle is known as the hypotenuse. So we will write it as OQ square. It is equal to OP square plus PQ square. So OQ, it is written given, it is equal to 25 square, and OP, that is the radius that we have to find, and PQ, it is equal to 24 square, or I will write it as 25 square minus times 24. I will transpose 24 from right side to left side, and then we are having the radius square, that is OP square. Or I will write it in this form also. OP square is equal to, this A square minus B square, so we will write it as 25 plus 24 into 25 minus 24, because A square minus B square is equal to A plus B into A minus B. So which implies radius square, that is OP square, is equal to 25 plus 24 is equal to 49, and in this side 25 subtracted by 24 is equal to 1, or I will write it as OP square is equal to 49, or I will write it as OP square is equal to 7 square. Square and square cancel out, so what we get OP, and OP, that is equal to 7 centimeter. What is OP, dear students? OP is the radius. So radius is equal to 7 centimeter. In this manner, dear students, we come to the conclusion that while the two sides of a right angle triangle, one is the hypotenuse and the second is the base, it was given, and the third side, that is the radius, and the radius I calculate here with the help of Pythagorean theorem. Hope you understand it very well. Thank you.